Okay, this is the P1 paper from January 2023. This is question number 10, and as it's quite a late question in the paper, it's more than one topic. If we look at it, we can see this is a cubic graph, obviously, here. Part B asks you to expand those brackets, and then part C, in order to do that, we need to be able to find the equation of a tangent. So 3 separate chapters that we're going to be looking at there, but let's make a start to it. So we've got this cubic and we've got this straight line, which is a tangent. It says use the given information to state the values of x for which f of x is greater than 0. So f of x is going to be greater than 0 there and there, but what that means is I need to work out these critical values here. So let's go ahead and explain to the examiner what we're doing. So for part A, if I want to work out the critical values, I would say for critical values, fx is equal to 0, which means that my cubic is equal to 0, but my cubic has very helpfully all been factorised. So we get 3x plus 20, x plus 6, 2x minus 3 equals 0, and if that's equal to 0, then each separate one. 3x plus 20 equals 0, that gives me x is minus 20 over 3. X plus 6 equals 0, which obviously gives me x equals minus 6, and 2x minus 3 equals 0, which will give me x equals 3 over 2. If I put those on the graph there, then this one is minus 20 over 3. This one is the minus 6, and then that one over there is the 3 over 2. So as I just said, we want in between those values and greater than that value there. So let's just explain that again. We'll write that down for the examiner. For fx greater than 0, that's going to be between minus 20 over 3 and minus 6, and it's also going to be x greater than 3 over 2. So there's my answers to part A. When's the graph greater than 0? Part B, relatively straightforward. Can we just expand that set of 3 brackets there? So yeah, hopefully you can do that. Let's have a look at it. 3x plus 20, x plus 6, 2x minus 3. I'm sure you've got your own method for doing this. I always multiply out those 2 brackets first and then multiply by 3x plus 20 afterwards. So let's do that. So I'm going to do x times 2x, x times minus 3. Then I'm going to do 6 times 2x, 6 times minus 3. So I'm going to end up with 2x squared minus 3x plus 12x, excuse me, minus 18. Tidy that up, don't rush it. You've got 3 marks for this, so just make sure you're not doing anything silly. If I'm going to make a mistake quite often, it's with actually copying down from one line to the next. So I'm checking that continually as I'm going through. Now we've got to multiply these 2 brackets out. I think this is easier actually, because it's just 3x times all of those 3, and then it's 20 times all of those 3. So hopefully if you practice these, you shouldn't really have too many issues with this one. That gives me 6x cubed, 27x squared, 54x. The power's going down each time there. So that was my pause, was just to check that I've got that. 40x squared, 180x, and minus 360. So that's all looking okay. Tidy that all up. So the 6x cubed, but then the x squared, I get 67x squared. The x's works out to be 126x, and the constant is just 360 there. Practice will make you quicker and more effective at doing that style of question. Part C then, so we need to go back and read the question now again. It says C is the tangent, line L is a tangent. Yeah, I can see that, and it cuts tangent here, And then what we actually want to find, if you read through the question, is we want to find when this tangent comes back and meets the curve again. We want to find that. Well, we can't do that unless we can work out the equation of the tangent. So actually this question is saying, can we find the equation of the tangent at that point there? So I need to know what's the coordinate of that point, and then I need to know what's the gradient of that point. Doesn't matter which way around you do it first. If I want to do the gradient, I've just found the function. I can differentiate it. That will give me the gradient. I'm actually going to find the coordinates of, let's just call this Q or something like that first of all. So for part C, I'm going to say for coordinates of Q, this is where x is equal to 0, so y is going to be equal to, and you can just put 0 into this function here, can't you? So it's just 0 plus 0 plus 0 minus 360, y is equal to minus 360. So I know now my point is 0, 0 minus 360. I want to work out what the gradient is then, when x equals 0, the gradient when x equals 0. Well, for gradient, if I've got y is equal to the function 6x cubed, 67x squared, 126x, and 360, the gradient is going to be dy by dx, isn't it? So differentiate that. You should have no problems differentiating something as straightforward as this. Multiply by the power, take one off the power each time. So 18x squared, 134x. Obviously, when we just get to the x's, it's just 126, and the 360 just goes there. So that's my gradient function. My dy by dx is my gradient function. It's the differential. If I want the gradient, when x equals 0, so tell us that. At x equals 0, m is going to be 18 lots of 0, 134 lots of 0, and 126 there is just going to be 126. So what was the point of me doing all of that? I'm trying to work out the equation of the tangent. So in order to work out the equation of a tangent, it's y minus y1 equals m, x minus x1. We've got x1, we've got y1, and we've got m. If you've seen any of my other videos, I always write it down like that. Firstly, because it just gives me a chance to just pause here and make sure I'm not putting in any wrong values. So the coordinate was 0 minus 360, 0 minus 360, and m was 126. Quite strange values there, but it's absolutely fine. No problem with that at all. So y plus 360 minus minus is equal to 126 x minus 0. So I'm going to get y equals 126x minus 360 as my straight line. Now, some of you brighter students might have said, sir, you already had that. You didn't need to do all that work for that. You knew what M was and you knew what C was, so couldn't you put it straight in? Yeah, you could do, but I'd like to go with the standard method for those students who just need a little bit more structure to a question. Then that's another way of doing it. But yeah, some of you may have jumped a little bit quicker at doing that, so it can save you a minute or two when we're doing it. So why was I doing that? Go back to the question again. The whole point about finding the equation of that tangent was because I'm trying to find P. And P is going to be where the equation, where the equation of the line hits the equation of the curve. So in other words, at the point P there. So if I'm finding P, for P, sorry, I'm just pausing to make sure I'm telling the examiner what I'm doing. For point P, two lines meet. Which two lines? The curve, 6x cubed plus 67x squared plus 126x minus 360. Again, make sure you're copying everything down properly. And the straight line was 126x minus 360. And now I just need to solve this equation. Well, what's really neat here, look, is that both of those cancel out. So at that point, I think, oh, well, I'm probably pretty happy that I haven't made any mistakes on this particular question as we're going through. We're going to get 6x cubed plus 67x squared equals 0. Take x squared out as a factor, which will give me 6x plus 67 equals 0. So I'm going to get either x equals 0, x squared equals 0, so x equals 0, or if 6x plus 67 is equal to 0, then x works out to be minus 67 over 6, which is not a very nice answer at all. I only know because I've gone through and done this previously that is correct. And going back and reminding ourselves of what the question was to find the x coordinate of p. So the x coordinate up there, what that value is going to be there, yeah, and it's correct at being minus 67 over 6. Okay, long question, but hopefully that all makes sense to you all.